Hi, this is Dr. Sweeney, and what we're going to be doing now is we're going to be looking at a hypothesis test, and we're going to do a t-test for the mean, and then we're going to use the critical value method in order to do this. So, what I'm looking at here is I've got this question. For the following experiment, you will use the data set body fat in the Sweeney stats test group. So what I've done is I've gone through and I've done the technology for you. And so body fat was collected from a group of 252 CrossFit athletes. The average body fat for the American population is 23.4. Tests the conclusion that the average body fat for CrossFit athletes is less than the average body fat for the American population. Test using alpha, so we should write that in, alpha equal to 0.05. Using technology, we find that x bar, our sample mean, is 18.94, t is equal to negative 9.1376, and we find a critical value of T alpha equal to negative 1.65. So like any other hypothesis test, what I'm going to first do is I'm going to figure out what my null hypothesis is so I know what I'm going to be rejecting. So this one is going to be a mu, right, because it's going to be average body fat. So it's mean, and that equals, for the American population, it's going to be 23.4. My alternative is stating that we want less than the average body fat for the American population, so mu is less than 23.4. Here's my HA. Okay. Now, what I want to do now is I'm going to say, okay, well, what kind of test am I going to be running? And so if I look in here, I know I've got a test for the means, and since I know I have the test for the means, I have two choices. Either I'm going to use the Z or I'm going to use the T. Now, the reason why we're going to use the T in this case is because I do not have the population standard deviation. Nowhere in here do I see sigma or my population standard deviation. So I use T because I lack sigma, the population standard deviation. So I lack sigma, the population standard deviation, and so consequently, I'm going to use T. Now, I'm going to be doing the critical value method, so I want to imagine or write into my whiteboard, okay, my distribution. At the middle is going to be my null hypothesis, mu equals 23.4, and my critical value now, okay, is I'm told is, here's Z alpha, or T alpha, excuse me, because it's t-test, T alpha equal to negative 1.65. Okay? Then I look at this, and my t-score, though, is way over here. It's way over here. It's t equals negative 9.136. So, t is in the critical region. So I will reject the null hypothesis. Okay, there it is. So there is sufficient evidence to reject the null hypothesis that the mean body fat for CrossFit athletes is 23.4. There is also sufficient evidence to suggest that the mean body fat for CrossFit athletes is less than 23.4. And so our finding, if you want to answer that last question we have, our finding is that in fact that CrossFit athletes are trimmer than non-CrossFit athletes, according to our test. Our test says CrossFit athletes are trimmer. We have statistical evidence to suggest that that's the case. There we are. That's it. So let's go over it real quick. I come in here, I'm reading my test, right? My test says, okay, here's the average for all the population. That's going to be my mu, 23.4, right? Population, everybody within the group, okay? My alternative is what it is that I believe. So its mu is less than 23.4, okay? I have my alpha 0.05 that helps to give me my critical value, my T alpha, and then I found my T value. So I imagine what it is, my distribution. I've got mu at the center, okay? I've got my T-score, and I only have one in this case because I only have just this left-tailed test. And what I have is that because T, right, is less than T alpha, right, okay? This is, by the way, my alternative hypothesis. My alternative. This tells me to reject the null. And then I ask myself, well, what am I rejecting? I'm rejecting the null. So my conclusion should have what it is that I'm rejecting. That null hypothesis is 23.4. And that concludes this test. That's the critical value method.